Thanks everyone for joining for the continued interest in this particular topic of generative AI in enterprise. There's so much going on in the market right now. It's so difficult to even keep track of like what is going on and what is not going on. I'm pretty sure like interested have heard about like Google releasing their own generative AI open source model called Gemma, Gemma. So that was the newest edition of the news. But anyway, so interesting thing is a few of my friends ping me over LinkedIn and they have been following all these discussions, presentations by different people for the last few months. And they told me like, Ujjal, this is all good, but then where do I get started? How do I even start using generative AI apart from like using ChatGPT and all? So this particular meetup, I thought, okay, maybe we'll go back to the basics and talk about like how to get started. So being said that, I'm Ujjal Bhattacharjee. I have started this generative AI in enterprise meetup group for the last couple of months, few months, and then we have been trying to like tackle different topics on a regular basis. So I see some new faces over here. So maybe we'll do quick one line of introduction, if that's okay. So I'll start with Muthu. Maybe like if you can just tell one liner about yourself.
Sure. I'm Muthu. I'm a data engineer. Basically, I have like some 15 plus years experience in data warehousing and business intelligence area.
Hmm.
Yeah, right now like we are like helping this the data scientists, machine learning engineers get the data.
Hmm.
So I thought like okay, we should land that side of it, right? Because then like end to end like what's going on, so that you can catch up on. Right. So that's why I was just Googling and then for meetup and then I thought like why not give it a try? And I'm here.
Yeah, absolutely.
Yeah,
So pleasure having you in this group.
sure.
I know like Hormuz, you have joined a couple of calls, last few calls, but we never got a chance to talk. So why don't you give a one-liner for yourself?
Hi everyone, my name is Hormoz and I manage a technical team and we work on basically we write program for pharmaceuticals to do clinical trials.
Oh, okay.
Um,
Wonderful.
I started on basically deep learning few years back, mostly on vision, but
Hmm.
lately since I think basically this generative AI is there, more interested in this. Yeah, so yeah, I just appreciate that what you do. This is great.
Okay, awesome. Okay. Nagi, Nagalingam. You're first timer joining this group. So if you don't mind, just to give a quick like one-liner introduction.
Yeah, hi, Uttal. I know you keep saying one line, but I was trying to say what in one line. One line, I'm very interested in Gen AI, and I'm a friend of Prakash, and we met last over the
Oh,
weekend, and he said that this is an interesting forum, and
okay.
so I've been in finance and tech for a few years.
Okay.
I manage many things on the street, so
Awesome. Okay.
so
Nice.
here I am. Thanks.
Awesome. And Prakash, you and me have already talked so many
Yeah,
times.
yeah,
But
no,
for Muthu and Hormos, if you can just give a one-liner.
no, it's been great. I attended a few sessions, and I find this to be every session I've learned something new, and that's really my intent, really to get to understand this space a little bit more.
Yeah.
And I was chatting with Nagi, as you mentioned, over the weekend, because that's the level of interest we have, right? To see what's really going on. And you made it real for us, right? Really saying you take the hype away. How do you bring it to life, and how do you experiment? So I'm in an experimental mode right now, as you know.
Yeah. Correct.
So hopefully, it'll result in something good. But it has just changed in just in the last 1 year itself. There's so much dramatic change, and now we anticipate much more going
Much
forwards.
more change. Yeah,
Yeah,
it's
what
so
you're
hard
doing
to
is
keep up even.
yeah, it is. It is. So
Yeah.
commendable what you're doing. Keep going. Thank you.
Okay. Awesome. So I'll keep going with all your enthusiasm and encouragement. So let me go ahead and share my screen and we'll take it forward from here. So today, this is our Generative AI in Enterprise 10th episode. And in fact, we should have done it in the first episode, but now at the 10th episode, we are doing a getting started session on generative AI. So today I thought I'll just take up this opportunity to talk about how to even get started using generative AI, right? So I'll just go through the usual stuff of introduction, which we have already done, some disclaimer, housekeeping, participant introduction, which we have already done as well. And then we'll open up for the topic of the day and then some interactive questions. And again, like it's a so small group, so feel free to stop at any point of time. Disclaimer, this whole initiative is my own, nothing to do with my employer. Smaller, very small group today. So, but irrespective of that, free to be on camera. It's optional, but we like to see you. You can also be on mute, or you can also be not on mute. So either way, it really doesn't matter. So now talking about generative AI project lifecycle. So we had a couple of sessions on AI evaluation, and one of this slide kind of talks about the project lifecycle of a generative AI use case. This is from deep learning AI. In this case, what they're talking about is that let's define the use case first. What am I trying to solve for? And then choose an existing model or pre-train your own model. Now, pre-training your own model is the complex thing which we typically want to avoid, right? We do not want to pre-train my own model. We want to build on top of models that are already existing. Now, if I cannot, then I'll go ahead and pre-train my own model. So we'll start with something simple, choose an existing model, and then maybe we all have tried our level best of prompt engineering using ChatGPT. But then there are also options of fine tuning existing model and use it in our use cases. And now I'm going to do a little bit more deep dive on the use cases and how to go about with it. So I'm not going to stop over here. And then the more important part is evaluation. And we are going to talk more about that. And then there is also this concept of aligning with human feedback. So we kind of like did some discussion around aligning with human feedback. We never really got into the depth. But and we are not going to get into the depth of aligning with human feedback in this particular discussion. So in this discussion, we are going to choose between an existing model, evaluation, how to optimize and deploy, and then go ahead and implement your model to build LLM powered applications. Let's go to the next slide. We also talked about using an LLM. So now the other thing that we have learned is there are different types of large language models that we can use for different purposes. Now, if I use ChatGPT, it pretty much does everything very good, but then it becomes very expensive very soon. So, and there we also talked about like small language models in the last session. We talked about like how this whole landscape is evolving, how many different types of the models are out there, and maybe I'll share the link to the LLM evaluation video. If someone is interested, you can take a look at it. But more importantly, the point over here is large language models are good at doing a lot of different things: essay writing, summarization, translation, information retrieval, but more importantly, invoke APIs and take actions. And consistently, like over a period of time, there are applications that are being built specifically in this particular area, invoke APIs and take actions on those API calls. So now we talked about the project lifecycle. We talked about different use cases, but this is very clear at this point of time. Our use cases derive the AI models that I'm going to use. So there is a definite direct correlation between the use cases and the AI models that we are going to use, right? Can I use Chat or OpenAI's LLM model for pretty much all the things? We can, but there may be for specialized use cases, there will be like specialized models that people have been creating even before ChatGPT came into picture. So use cases definitely derive from the models that I'm going to use. Now there are three types primarily, and now actually there is four type, right? So there are few different types of generative AI use cases that are available in the market. One is like text generation, the other one is image generation and sound generation. So with that now we can always like do text generation, right? I can say, okay, tell me a story, it will tell me a story. We can also do image generation nowadays with DALI and integrated with ChatGPT. There we have also talked about in other sessions, we talked about like AI tools which can generate sound and music and songs for us. And now in the last week, OpenAI released a model called Sora, which can actually generate video also. So I have not captured that over here. But our focus right now is on the text generation part. And maybe in the future, we can get into the deep dive of image generation and sound generation. Now, for our text generation use case, and if I go back 2 slides back, right, we talked about like summarizing, translation, all falls under the text generation use case, right? We can choose between different models. Some of them can be proprietary, some of them can be open source. For example, ChatGPT is a proprietary technology, right? Even Google has released this new technology called Gemini a few weeks back. AWS has its own Titan, etc., etc. So under proprietary, there are a bunch of them over here. So OpenAI GPT, Google Gemini, AWS Titan, Anthropic, Claude, and many more. If you go to openrouter.ai, you will get a list of all the models that are available. In the open source, Meta has Llama, Google has Gemma, Mistral is there, and there are a bunch of them. Like there are hundreds of them. There are too many to actually keep a count of at this point of time. Right? So we talked about models, we talked about proprietary, we talked about open source. Now let's go back to the use cases, right? So in the text generation use case, what are the different use cases that is the most popular? The most popular use case right now, everyone is building, every company is building this particular use case, right? And people are getting better and better at this. And this is the most common use case, is document understanding and interaction with the document. So I have a bunch of documents in my organization. It can be PDF, it can be Word document, it can be text document, it can be transcript from customer service agents, representatives talking to customers, so on and so forth, right? Bunch of documents, and I want to have a clear understanding of the document, and I want to interact with the document. So that is the most common use case. Another use case that pops up is virtual assistants with specialized knowledge. So I'm building a bot on top of my documents and creating a virtual assistant agent so that it can interact with customers directly. So customer says, "Hi, how are you? How can I help you?" And so on and so forth. The conversation starts just like ChatGPT, but now with specialized knowledge of my organization. The the third one, which is very similar, is like intelligent agents for task automation. So, for example, now if I have started talking to this particular customer, and based on the customer request, I want to go ahead and complete an action. And so that's where the agents comes into picture. And we are going to talk more about agents. So that's where agents comes into picture, and it has the ability to complete a task. And then another use case is automated content moderation. So someone is generating some content, and there can be a bot present who reads through the contents, goes back and like checks the corporate guidelines and make sure the content that is generated is not against the guidelines, like putting some guardrails over here. But moreover, it falls under customer experience, data analysis, fraud detection, process optimization, so on and so forth. Like there are hundreds of other use cases, and every day there are new use cases coming up. So at this point of time, we talked about use cases, we talked about models, we talked about proprietary, open source. So now let's see if I can start putting these pieces together. What are the platforms that are available? Can I build an application out of it, right? So let's go to the next slide. And so now we'll talk about hosting or deployment of my model. So a large language model or any other AI model needs to be deployed somewhere, right? So I need a place to host my language model. I can buy a computer and host my language model over there, but it will require a lot of GPU. And in this serverless world, who buys a computer with a lot of power, right? No one does that, right? So maybe I'll go ahead with a cloud hosting solution, most of the cases, right? Which is cheaper, pay per use, and I don't care about like all the infrastructure and all. So I'm putting that on-prem hosting thing aside and moving ahead with cloud hosting solution. Now for cloud hosting solution, what are our options? Our options are typically Azure, Google, AWS, and maybe some proprietary other solutions. But these are the three big players in the market, right? So, I mean, we can go with any one of them, really doesn't matter. But at this point of time, let's choose one and move ahead in the journey. So, in the next one, let's see what are our options within AWS, right? If I choose AWS, I have the option, two options primarily to host a large language model. I have AWS SageMaker and AWS Bedrock. Now, what is SageMaker and what is Bedrock? Bedrock is a very new service that got released, I think, 2 months back in November. So, what they have done is they have actually made it extremely simple to consume a large language model. They have created a platform and they have started hosting like different language models. And only thing that we have to do is like click a button and start using the Bedrock APIs through a Python code or something like that. Now, Bedrock is very new, but that does not mean that people were not able to deploy AI models in Sage AWS earlier before Bedrock. So, what were the options? SageMaker was one of the options. So, where you can actually take any model, you can build your own model, you can take a model from open source model and deploy it within SageMaker, and then actually start consuming it. It's a little bit more involved. It's a little bit more expensive also, but it comes with a lot of flexibility. So over here within the SageMaker and the Bedrock models, of course, I think the easiest one is to go with Bedrock because they have done all the hard work. And pretty much they have created this whole platform, and then we just choose the model that I want to use and start using it. They've also given a nice playground and where I can do chat with the models and see like what kind of outcome that I'm getting. It's a complete solution versus SageMaker is more of like a raw tool that I can use to deploy any model, and it's very flexible. So we can fine tune the model. We can do a lot of things over here. So now let's see what are my next options. Okay. So basically, at this point of time, this is clear to me that, okay, I need a language model and I have so many options. I can go with Titan. So in this particular example, I'm going with AWS Titan, which is a proprietary model from AWS. It falls under this whole AWS Bedrock platform. And then I can write a bunch of Python code to access AWS Bedrock, which will make use of Titan to give me the solution that I'm looking for, right? So in this case, it's a very simple code, a few lines of Python code. You say, hi, how are you? It will make a call to Bedrock. Bedrock will make a call to a Titan. It will give you a response back saying, I'm great, how are you? Right? It just acts like ChatGPT. But in an enterprise, it requires much more than just this few lines of code, right? So that's where things start becoming a little bit more and more complex, right? So let's see what are the other complexities over here. So the moment I have this little Python code connecting to Bedrock and maybe Titan behind the scene, then my use case will become a little bit more complex and say, hey, I know like you can connect with Bedrock and say, hi, how are you? And it will respond back with a response, like come back with a response and say that, okay, I'm doing great. How are you? But that's not going to be our use case, right? Our use case, we talked about like um, researching documents, and then we talked about agents. I should be able to like talk to a database. I should be able to talk to PDFs that are within an S3 bucket, or I should be able to make some API calls outside to do some more functionality over here. So maybe this is an architecture at this point of time. So Python code, talking to Bedrock, talking to Titan, and then behind the scenes, we have the same Python code, maybe talking to a database, talking to an S3 bucket, a PDF, and then making some backend API calls also. So that this can be a fairly good architecture, but it's not great, right? Because there are so many other gaps. So let's see what are the gaps. So typically, the gap over here is not really gap, but it's just too complex to write all this code. How do I even read a PDF, right? So that becomes a bigger question. How do I connect to the database? Or are there any libraries to do that? How do I connect to Bedrock, right? And then what happens? How do I connect to this backend APIs and all? So I need a little bit of more structured way of doing it rather than writing all the code from A to Z. So that's where frameworks like LangChain has evolved over a period of time. So, and LangChain is not only this one framework. There are multiple frameworks out there. LangChain is the most popular framework, but there is also Llama Index. There is also like Single Store has a bunch of. I mean, there are now numerous of them. Even AWS has their own frameworks that we can start using. And Python has its own libraries also to connect, do a lot of these things. Eventually, all of these arrows are API calls, so really doesn't matter. It's an HTTP call that I'm making to an outbound database, to an S3 bucket, to an API, or to backend API calls, or to Bedrock. So really doesn't matter. But the LangChain makes our life extremely easy. It just abstracts out all the complexity out from there. So now my Python code uses LangChain framework to do all these things behind the scenes, and I'm done. Now, talking about the code, I'm not going to do a demo of the code and how it works. There are tons and tons of GitHub repos out there. I'll put some links which I found to be useful. So if someone is interested, can take a look at it. Now, at this point of time, I'll stop for any question or any thoughts that, hey, I mean, what else is missing over here? What do you guys think?
Paul, this is Nagi. Quick question. So, am I right in understanding that Bedrock is a service of AWS
Correct.
on the same lines as SageMaker? And then Titan is a model in this service?
That is correct. Yep. And
Okay.
similar to Titan, there are like tons of other models that AWS has started incorporating.
Okay.
Open source, proprietary, all of them.
Got it. Okay. So, is Titan more appropriate for document processing, or these models, are they geared to any particular scope of processing?
No, these are foundational models, very, very
Okay.
generic.
Okay.
If a use case demands a fine tuning of the model, then it has to be done. And that has to be done using SageMaker, not Bedrock. So Bedrock gives you the model out of the box, and you can choose between
Mhm.
models. And how do you choose between models is that's where the whole evaluation framework and the concept of evaluation comes into picture. And
Got-
that's where it becomes muddy and gray, because everyone is talking about like generative AI project. But if you look at it really in the industry, I do not know how many are really large scale generative AI project that are confidently deployed, because that's where the complexity of evaluation comes into picture. That how do I make sure that this guy is giving me a correct answer? And even
Uh,
in ChatGPT, when I use, it clearly says that AI generated answers may be incorrect. So use it in your own risk or discretion.
Got it. Okay. I guess possibly the differential rate of there are several SMEs, but they don't know AI. They don't know the models and what it can be appropriate for them. And
Mhm.
similarly, model experts don't know the subject matter. So there's a gap here, and it'll take time,
There
I
is a
guess.
gap. There is a
Got
gap, and that's where the new industry that is evolving is fine tuning industry. That is the biggest thing right now, I believe, because building a framework like this and building an architecture like this is easy. There will be hundreds of use cases or tutorials out there to build this thing, right? And the hundreds of videos out there, but no one is going to talk really about the depth of the complexities of the evaluation. So that's where it becomes the niche area, that who can confidently understand a domain and give the confidence score that the outcome is good. And how do I track that? And that's where comes opens up the next part of the slide, which now talks about. Oh, before that, just a quick addition over here. What AWS has done, and I'm leaning towards AWS is because that is an area that I'm close to. But I've also like seen similar things in Azure, and I'm pretty sure Google also has something similar. So AWS created another abstraction layer to make life simpler, which is called knowledge base. So you can take all your documents, create a knowledge base, and then use Bedrock and this knowledge base with very minimal coding and configurations. It's all configuration, less of coding. But then that also has a lot of gaps. And That also needs a lot of evaluation before we can productionize it. So that makes it even more interesting. Overall, mhm,
So when this foundational model like a Titan is available, is that is that static or does it get updated with new information or new results?
no, it does not.
It does not.
It is
So
static. So
it
it's
is
static. Yeah.
so there is this whole concept of learning, right? The models learn or it kind of
Yeah.
is self.
Yeah.
How does that happen? Is it based on the inputs that it has received historically? What is it typically based on?
Yeah. And that's where the fine tuning comes into picture.
Okay.
So if you really want to make the model learn, we have to actually, you remember like in the first slide where I was talking about human feedback loop,
Yeah.
right? And we have not touched that topic, but maybe in the next session we can discuss more about like how to fine tune a model.
Okay.
But this particular example, you're correct. The model is not learning anything. You are actually augmenting the model with context from your data source. So basically you are saying that, hey, this is the data, summarize the data for me. It's like you go to any website, go to cnn.com, copy this whole thing, put it into ChatGPT, and say summarize or give me bullet points out of it. So basically, what you're doing by doing that, you're not actually making ChatGPT better. You are actually giving an extra information. It's called in context learning. So you're giving some more context to the ChatGPT, maybe a large document, maybe a PDF, maybe a megabyte of customer interaction, and telling ChatGPT, this is my context, use your own intelligence to give me the answer. And this is my question. And the question is, tell me the sentiment of the customer interaction.
Okay. All right. That makes
In
sense.
this case, you are not now. Now, here is a catch. When you give the context, when it gives me the answer, in ChatGPT, we have this whole like button, right? Now, the moment you click the like button, and then if you have given consent to ChatGPT saying that you can use this data to enhance your large language model, they will do that. But you can also say that don't use my data to build your large language model. So they're not going to do that. So they're going to use open source or publicly available information to enhance the language model. And that's where today it's Titan 1, tomorrow it can be a Titan version 2. So then you have to point to the newer version of the model to get the better outcome. But that doesn't mean, in this particular case, the scenario that I'm showing, it doesn't mean that Titan is getting better by using your data. And that's what this AWS and Google and Microsoft, they give you the assurance that we are not going to use your data to make our language models better. So your data is in your domain, in your VPC, within that boundary, and you are getting a copy of the language model. We are not using your data to build a large language model. It's a good question. So I'll move on to the next topic. So now I have, if you see, there is a little more enhancement that I've added. So we talked about AWS Bedrock knowledge base, and then I've added this whole thing about like vector DB. And if you go back to, there is one session that we did on MongoDB vector search, and where the person was talking about how AI models depend on vector databases. I'm not going to get into the details, but maybe if you need more information, I'm happy to share. But how AI models need vector databases to like build, interact with your data. So this is a requirement. So basically, the point over here is AWS gives you all these things out of the box, right? You just click, 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 and you're done, pretty much. Now, the moment it comes to evaluation, whether this whole thing is good or bad, and then how to fine tune the vector database, how to make it even better. So, there are different kinds of fine tuning that we can do. We can fine tune a large language model, we can fine tune the context as well. So, basically, if I'm searching for so for example, I have this whole knowledge base and I have a bunch of documents within that knowledge base, and you want to search for information within that knowledge base, and then you want to search for information within the knowledge base, and then you go back to the model and say, okay, complete or analyze or summarize or whatever you want to do based on the context. So this whole search is a completely different ballgame altogether, and it's another domain to how to make this search better so that I can get that context give that context to the large language model so that it can come up with an action or take an action. Sorry, come up with an answer or take an action. So all of these are like a little bit involved topic, but sorry, little bit involved topic. But I'll try to move on and see like now what does the architecture look like end to end at a very very high level, right? So let's move on to the next one and see like what does it really mean. So now we talked about vector databases, and I talked about like tuning the vector database. And then now the moment I said vector database, there are so many options, hundreds of options over there. AWS has open source. There is a Chroma open source software. Pinecone is one of the leading vector databases, and there are many more. Like in one of the session we saw Mongo database, right? Also supports vector. Redis supports vector. Everyone now supports vector. So which one to choose for? So that is also another problem to solve. So there are so many problems to solve even before we come to the point. And that's where AWS is trying to give this whole thing about like you don't worry about all this complexity. If you really want to build a solution very quickly, use knowledge base, use Bedrock, build your application, make some API calls, and you're pretty much done. Then you do the evaluation and make sure like whether it's working for you or not working for you. Because most of the cases, people spend in the plumbing part so much of time and energy that by the time it comes to evaluation they're like, oh my god, I'm already tired. So I think AWS did a great job. I'm pretty sure Google and Azure also has something similar in that lines. So I'll move on. So we talked about vector databases. Now it comes to the actual problem statement, like, so why this is so complex? Because, and the complexity is because till now, or not till now, I mean like pretty much everything is deterministic in our life in the software world, right? So if I'm writing a for loop, I know exactly the for loop, how many times the for loop will run. If I'm writing an if then else logic, that is also hard coded in the business logic, and the outcome is extremely deterministic. So if the customer says yes, do this. If the customer says no, do that, right? Whereas the moment it comes to machine learning, or in this case generative AI, the answers are probabilistic. So it can be good, it can be bad also. So that's where the whole evaluation thing comes into picture. So let me go ahead and attach this guy, download. Somehow I'm not able to see my file, all files. Okay. So ideally, I have uploaded a document. I should be able to chat on the document, right? So let's see what was that? Somatosensory. I have no idea, by the way, what is this? What is somatosensory, right? And the idea is like it should be able to, sorry, delete. I don't know whether it's going to work or not. I have never tried it. Okay. Okay. So now it's working. So basically the idea is like I have given you the PDF. Basically, I have given you the context. Now give me the response, right? So in this case, I can see that Claude instance is giving me a response back. GPT-4 is giving me a different response back. Gemini Pro is giving me a different response back. And then Palm 2 is giving me another response back. Now, which one is correct? And that's where the whole evaluation matrix comes into picture, right? There is no right and wrong. So the answer can be probabilistic is the point that I'm trying to make. And that's where the evaluation becomes so important. So the moment you have a probabilistic response, we need a ability to actually evaluate the response. And we also need an ability to put some guardrails so that it doesn't spit out anything bad or something out of the policy, right? So that's where it becomes very, very important to have an evaluation framework in place. We also talked about like cost optimization and observability in our last call. And so if I now put all these pieces together, now the complexity a little bit increases. So now it's not only the Python code, not only the LangChain framework, not only AWS Bedrock, not only the model, but also we are talking about knowledge base, vector databases, S3 bucket, maybe backend API calls to do some action, or make or take a customer's request, process it by making an API call, and then the response that is getting generated use guardrails. Like AWS has Bedrock guardrails. We talked about Llama guard. in the last one. We also talked about Langsmith. So I'm trying to put all the pieces together that we have talked in the last few sessions and see like what does it really mean. So maybe this is an architecture that might work. Okay. So we have all the pieces of the puzzle in place. So I'll stop over here for more question and then we'll go to the next one. Any question, anyone? Okay. So no question. So I'll move on to the next one. So now we talked about Python code. How do I run the Python code? Where do I run the Python code? So in my laptop, I can run it in a notebook or a Google Colab. But in the real world, it can be a Lambda function running or an ECS task running or yeah, most likely a Lambda function or an ECS task or an EKS task running somewhere in AWS. So overall, this is the complete picture at this point of time. So now we have a Lambda function which has a Python code deployed. It's using a bunch of frameworks like LangChain or Llama Index. It uses some backend AWS services like AWS Bedrock, which uses a model. It is, I'm showing Titan, but it not necessarily has to be Titan. It can be anything else. Maybe we'll use AWS Bedrock knowledge base, some vector databases. Maybe we'll make some outbound API calls. We'll use some guardrails, and then we'll also have some observability platform so that I can monitor my output as well as manage my cost better. And then based on that, now it's a cycle, right? It goes back to this whole data machine learning life cycle. Now I go back to the code, maybe tune the model or choose a different model, different database, validate the guardrails one more time, use some evaluation like LangChain as well. I forgot to add the LangChain framework over here for evaluation. And then use some observability pattern. Go back to Langsmith and see like the observability of like what is the cost, what are the output, and then give some scores. Now it's much broader than that. This is just a view of what is the art of possibility at a very, very high level without trying to get into the complexity and also not being like super high level. So that way, like it's all sales speech. We're trying to be as close as possible to the technology, but trying to dumbify it so that we really not jump into the coding part of it because it's just more than that. So that's pretty much it. So that gives me a complete landscape of like how to get started with a generative AI project and what does it really mean from an implementation standpoint. I think that's all I have today. Any questions, anyone? We have like 5 minutes left.
Hey, Ujjal, I want to thank you, man. This clarifies all the different piece parts, and as you keep repeating, I think it's fairly complex. I mean, there is a lot of stuff involved, and personally, I think it'll be great to see a real success out in the market. I mean, there are a lot of productivity gains that people are talking about, and Copilot, that Microsoft has released the Copilot, so I'm sure people are using those kind of tools.
Those are productivity tools to enhance my productivity. It's similar to using ChatGPT. I can use ChatGPT to write a Python. In fact, we did that. So there was a request, and someone had asked me to, hey, can you write this thing for me real quick? I have no idea about Python and all. I asked ChatGPT to write me a Python code, and then I mean, like we have this basic knowledge of like the foundational programming, right? I don't do a lot of coding nowadays, but then it was interesting. I asked ChatGPT to write a Python code. It wrote. I tried to troubleshoot. I took the errors, went back to ChatGPT. Hey, help me with the errors. It kind of like gave me some direction.
Nice.
It came back. So iteratively, I was able to build something out in a night. Copilot is similar, productivity tool. So organizations can start using it to make the developers better. But in a real world use case, when it comes to document search, and we think about it, like the moment I use Copilot and all, you are always having a human in the loop. You're not asking Copilot to write a code and put it into production.
Yeah.
You have the developer in the loop.
Yeah.
Right. So a human is always in the loop. The moment I have use cases where I take the human out, put the AI in the hot seat, that becomes a very scary part because it's all about the probabilistic outcome and the evaluation that is required. So how much I can gain confidence of my evaluation frameworks and the scores, and how much I can fine tune a model. The moment you go to fine tune a model, that's an even bigger project now at this point. Because now we are talking about like machine learning engineers, data engineers, etc., etc. So, so yeah, there are positive, negative on both the sides, and it just becomes more and more fascinating to see like how enterprises kind of evolve from here.
Yep.
This is really helpful. I mean, just got I mean, a good overview for the very first time, so it's really helpful. So I just have like a very basic question. I can tell elementary question. So how is this model different from a database? Because all these years we are used to like putting something inside a database and then we run a query, right? So it gets that, right? We understand that. How is this model different? Like what is this like? What makes it act smart? I mean, like can you shed some lights on that?
So if I say good morning, you will reply back with a good morning, right? Because we are tuned to that. It doesn't require you to like go back to your database and think, okay, if this guy says good morning, and then what do I say? So basically, that's how we have learned. If someone give me something, I tell thank you. It automatically comes, right? We don't have to think about it. So the way that I understand, and again, I am not a machine learning expert. The or I'm not a I wouldn't say I'm a mathematical genius or a data scientist over here. So basically, I'm just like any one of you, trying to understand how it works. So the way I understand is it's a mathematical model that has been developed with multiple iterations, and it knows. So if you give it a prompt saying that the cat, it will, and say complete the part, it will come back with the statement that cat is running. It really doesn't know.
Yeah.
Like,
So this is where
the
like see
next
in a
time when
data.
you ask the cat, it might come back and say the cat is chasing. The next time when you ask the cat, or when you ask that, okay, now the cat is chasing, it will come back with a response saying that cat is chasing behind a rabbit or something like that, right? So it has been fed, hundreds and billions of parameters, and that's why you see like GPT-4, they'll announce, right? GPT-4 has so many billion parameters. So it has been trained with so much of parameters that if you ask a question, it will give a random answer. And the random answer is almost correct to whatever a human being would say. So now the thing is, it happens to us also. Like, so suppose just before exam, like we study so much, now in the exam hall, I'm like completely confused, like what to say. So not necessarily if you feed a language model with so many billions and trillions of parameters, it might also start giving you a wrong answer because it's like has so much of information. It might also end up giving you weird answers, and that's where it becomes even more interesting. But does that answer, Muthu?
Yeah, kind of.
Kind of
Yeah,
like
it is.
trying to simplify it, but I can share you some really good
Yeah. So yeah, I mean,
material which
yeah,
is
my
going to
next
talk about
question
like.
is like, where do I start? Like, I mean, you kind of like went through like different tech landscape, right? So
Mhm.
what is where do I start? Like,
I can share some very good GitHub articles, and you can take a look at it. But a very good use case is this one, right? If you really want to experiment, you can start by writing a Python code which uses the framework called LangChain,
yeah,
and you can go to AWS, create your own free account, go to Bedrock, choose a model, create a knowledge base, put some data in S3 bucket, right? It will automatically create a vector DB for you. Use that knowledge base. Now use this LangChain framework to interact with Bedrock knowledge base and make some API calls, and then you will start building applications on top of it. So that's how you get started. And then to make it even more better, now you can actually go ahead and make some API calls outbound if you really want to like be creative and experimenting. So make some API calls outbound, and then you can also add Langsmith for observability, and but these are optional. So I wouldn't worry about this part. If you really want to get started, just go to GitHub, search for a YouTube video, a simple chat on PDF use case. There are hundreds and hundreds of them. Just download one of them and start experimenting. If you go to AWS's if you really want to like do the experiment and all, AWS has a bunch of GitHub projects that you can actually play around with. Make sense?
Sure. Thank you. Thank you.
Okay, so we'll wrap up 9 o'clock. I know, like but we'll catch up later then.
Thanks, Ujjal.
Thank you, Prakash.
Thank
Great
you.
session. Thank you. Bye.
Thank you very much. Bye.
You're welcome. Bye bye.